Hello viewers, welcome back to my channel Experience Physics. And in this class, we are going to discuss about some contents under the chapter Motion in a Straight Line. This is given in class 11 Physics. These are some contents we are going to discuss in this video lecture: distance, displacement, speed and velocity. Distance, we know. Let me consider two positions, position A and position B. An object moves from position A to position B. This way it is moving. An object is moving from position A to position B. The length of this path is known as distance. The length of this path. In contrary, if I measure the length of this line, it is displacement. This is the actual length of the path in which the object has moved. Both the distance and the displacement describe the motion of the object, how the object is moving. If it is moving in this direction, it is called, in this path, it is called distance. This is a straight line connecting the two positions. This is starting end and this is finishing end. So, the arrow is important for displacement. It is moving from A to B, the object, right? So, distance is a scalar because here there is no direction is important, whereas displacement is a vector. Here direction is important. If the object moves from B to A, it is negative direction, right? So distance, this is the actual way of the object's travel. This is the shortest line or the straight line connecting position A and position B. That is position, starting position, and this is ending position, right? Fine. This is distance. The SI unit is meter and displacement also the SI unit is meter. Usually letter S will be used to denote displacement or distance, right? If direction is not important, you can consider the magnitude only for distance, right? Then speed. If distance over time is taken, this is known as speed. Whereas if displacement over time is taken, it is velocity. Since displacement is a vector, velocity is also a vector. Displacement is a vector. So velocity is also a vector, right? If you use the symbol, you can draw one bar over it to mean it is a vector, right? So whereas distance by time, since distance is a scalar, speed is also a scalar. This displacement over time is vector. This is vector and this is also vector, right? So the unit is meter per second. Meter per second. For velocity also meter per second, right? So this is the simple definitions for the terms we are going to discuss here. Distance, the length of the actual path in which the object has traveled. This is the straight line connecting the two positions, right? Distance over time, speed. Displacement over time, velocity, right? Let me take one simple example. Whereas these are the positions, let it be the home. one person. This is his office. He walks in this direction, this way, in this direction, because straight away he cannot walk. There is a path here, so up to here he is moving, then he is moving horizontally. There are so many streets, assume. Let it be 3 kilometers. Let it be 4 kilometers. So the actual distance is from home to office 7 kilometers. The actual distance is a distance. Then displacement, if I join the home and office in this way, the shortest line or the straight line, only one line, straight line, right? So I can find by using, this is looking like an Pythagoras, looking like a right angle triangle. So Pythagoras theorem, we can use 3 square plus 4 square. So this is 5. 5 kilometers is the displacement. So in this example, what we have understood that displacement will be less than distance. In this example, right? Assume a bird is flying from this place to this place. The person is walking from home to office in this direction. Assume a bird is flying from this place to this place. The bird cannot or need not take these routes, right? The bird will fly in this way, straight away, right? The bird's travel or bird's path is this line. The bird's path, right? In this case, this is for the person. In this case, displacement is equal to distance. This is for the bird. Displacement is equal to distance. So, displacement cannot be greater than distance. This is the concept. Displacement, either it must be less than the distance or the maximum possible values, it is equal to the distance. It never becomes greater than the distance. So this is what we learn from this simple example. This is the person's path and this is the bird's path. Right, some numericals we will try to solve. This is one question. The numerical ratio of average velocity to average speed. Average velocity, V average, is equal to displacement over time. Then average speed, distance over time, total distance in fact. This is total displacement. Always lesser than 1. What we have seen here, displacement is less than distance. Displacement can be equal to distance. So V average is equal to displacement over time. Average speed is equal to distance over time. The options are always lesser than 1, always equal to 1. So since velocity is taken from displacement over time, always lesser than 1 is possible. Always equal to 1 is also possible because the displacement and the distance can be equal in the bird's case. Always more than 1, it will never happen. Since there are multiple answers, you read the fourth option, equal or lesser than 1. So this is the right answer, you must choose. You should not choose option A or B. Option D is the right answer, appropriate answer. So this question, if a body starts from a point and returns back to the same point, right? This is the position. The body starts and returns back to the same position. It travels, and again it is returning to where it was started, right? Then its average velocity is 0, but not average speed. What is average velocity? Average velocity, displacement over time. What is the displacement here? What is the displacement here? It is starting at this point, it is returning the same point. You cannot connect the starting end and to the ending end, right? So displacement is 0. 0 by t is equal to 0. So average velocity is 0. This is right. But not average speed. Average speed cannot be 0 because it has traveled some distance. It has covered some distance. So this is also true. Average speed is 0. This is wrong. But not average velocity. Both average speed and velocity are 0. If it is 0, this is also wrong. Average speed and velocity depends upon the path. No. Average speed depends on the path, but not velocity. Velocity depends on the two positions, not the path. Starting position and ending position, right? So average speed depends on the path, not velocity. So option A is right. Right. This is one concept, very important formula we are going to derive using this formula. I am going to solve few problems in this video lecture. You please listen to this topic carefully. Average velocity of a body, if it covers n equal distances with different velocities, d. So this is one starting place and this is ending place. Assume this is two towns. They are joined by a straight line. Starting place, ending place. Up to this d distance, velocity is v1. A vehicle is going, you assume, velocity v1 meter per second. Then another d equal distance, d, yes. But the velocities are different. v1, v2, v3, different velocities. At each place, different velocities. Up to n times of the distance, right? So this is what given. The question is to find the average velocity. Average velocity is equal to, this is the formula, total displacement over total time. Total displacement. For speed also you can use, because it is a straight line. So for speed also you can use, this is the traveled path, right? So at the end of this discussion, we will get one formula. That formula first I will write. It is easy to remember. N by V is equal to sum of 1 by V. You can remember this formula rhymingly. N by V is equal to sigma 1 by V. N by V is equal to sum of 1 by V. So this is the formula we are going to arrive at the last step, right? V average is equal to total displacement over total time, right? V average is equal to total distance d plus d n times. So total distance is n into d upon t1 total time, t1 plus t2 plus, in this interval the time taken is t1 seconds. In this interval time taken is t2 seconds. So I am going to add all the times plus t3 plus dot etc. up to nth time interval, right? So nd, this is time, total distance is ND, time we can write d divided by distance by velocity. Distance by velocity, time we can take cross multiply. So d divided by at t1 v1 is the time. Similarly, distance is d v2 plus d v3 dot plus d divided by vn. D we are seeing common, we can take it outside. N d upon d of 1 by v1 plus 1 by v2 plus 1 by v3 plus dot plus 1 by vn. So this d can be removed. This side it is v average. So v average is equal to n upon 1 by v1 plus 1 by v2 plus 1 by v3 plus dot plus 1 by vn. This is sigma sum of 1 by v, sum of 1 by v up to n intervals. This side it is v average. So we can cross multiply it. I am taking v average here. So n by v average is equal to, it will come here, sigma 1 by v. This is the relation. N by v is equal to sigma 1 by v. So since sigma is used here, so this is 1 by v1 plus 1 by v2 plus 1 by v3, any number of intervals, right? Here there is no suffix here. There is no suffix here. It means it is understood that this is the average, v average, right? Here v average is available. You please remember n by v is equal to sigma 1 by v, right? So this is the relation. This relation is very, very important. You please learn it. It is very, very important. Using this relation, we are going to solve few problems one by one. Let us see them. A vehicle travels half the distance with a speed 24 km per hour and the other half with a speed 48 km per hour. Then its average speed is speed as well as velocity. If no direction is important, we average formula, we can use it for average speed also, right? So the formula what I have taught you is 1 by v is equal to sigma, n by v is equal to sigma 1 by v. So this is v average, right? N of the distance, then another half, right? So n is only 2. 2 divided by v average, then this is only 2 intervals v1 plus v2. Instead of v1 we will write 24, instead of v2 we will write 48. Then this is 48. 48 is taken here, then this is 2, this is 1, 3 divided by 48. This is 2 by v average. 3 v average by cross multiplying 2 into 48. Then v average is equal to 2 into 48 divided by 3. So this can be removed 16, this 3. So the answer is 32 km per hour. The unit is kilometer per hour. So option A is correct. So remember this formula, n by v is equal to sum of 1 by v. You need not start from the derivation, right? A car moves from A to B with a speed of 30 kilometer per hour and from B to A with a speed of 24 kilometer. Position A and position B, it travels 30 kilometer per hour, and from B to A returning 20 kilometer per hour. From B to A it is returning, right? The average speed of the car is, what is the average speed? Average speed, what is? Again I will use this formula, N by V is equal to sigma 1 by V. What is N here? A to B, B to A, right? Actually, if you consider the total distance, 2 times of this distance, right? A to B, B to A. This is 1, this is 1, right? So N is equal to 2 here. This is V average. For speed also I am using the letter V, don't confuse here. 1 divided by V1, 30, plus 1 divided by V2, 20. So this can be 60, 2 plus 3, 5 divided by 60, 2 by V average. So this side, 5 into V average is equal to 2 into 60. So V average is equal to 2 into 60 by 5. So this is 12. Average speed is 24 kilometer per hour. Average speed. I am using V the letter, but this is speed here, 24 kilometer per hour. Next problem, a car moves a distance of 20 kilometer. So total distance is 20 kilometer. It covers first half of the distance at speed 100 meter. First half 100 meter per second. Second half with a speed V meter per second. If the average speed of the car is here, average speed is given. In the previous 2 problems, we calculated average speed, but here in the second half, what should be the speed? Then the value of V is what? This is in the question. So 2 halves. So N is equal to 2. As usual, we will write N is equal to V is equal to sum of 1 by V. N is equal to 2 here. V average, in fact this is average. V average is available 40. 1 by V1. V1 is 100 meter per second plus V2 is V itself. This is in question. So 2 by 40 is equal to 100 V. This will be V plus 100. 100 V. 1 0 I can remove. So this is 2 into 10 V. 20 V is equal to 4 V plus 400. 4 V, if it is taken here, 20 minus 4 V is equal to 16 V is equal to 400. So V is equal to 400 divided by 16. 20 V minus 4 V, 16 V, 400. V is equal to 400 divided by 16. 4 times 4, and this is 100. 100 by 4 is equal to 25. 100 by 4, 25. The answer is 25 meter per second. Option D is right. Next question. A body moves from A to B with a constant speed 20 kilometer per hour. A to B. It moves with 20 kilometer per hour. And then B to A with a constant speed 30 kilometer per hour. Then the average velocity, not average speed, average velocity of the body is what? Velocity is displacement per time. V average, this is velocity displacement over time. A to B, first it is moving, then it is coming to B to A. So the position is again A. It returns to the same place where it was started. Right? A, from A it is moving, again it is coming back to A. So displacement here 0. Displacement is 0. So V average is also 0. 0 by T is equal to 0. Answer is 0. Option C. Right? Though it traveled some distance, displacement is the shortest length between the starting point and the ending point. Since the starting point and the ending point are one and the same, where it has started, it is returning back to the same place. So 0 must be the displacement. Next problem, a bus travels the first one-third distance at a speed 10 km per hour. The next one-third distance 20 km, first 10 km, then 20 km, and the last one-third distance 60 km. 3 intervals, one-third, 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 right? The average speed, V average, is what? Again we will use the formula, N by V is equal to sigma 1 by V. N is equal to 3, one-third, one-third, one-third. So totally N is equal to 3. 3 divided by, this is V average. Please remember this is V average because I am using the sigma sign here, V1, V2, V3. This sign, it is, the suffix is average. V average is equal to 1 by V1. V1 is 10. V2 is 20. V3 is 60. 60, let us take LCM, 6 plus 3 plus 1. So this is 10 by 60. 3 divided by V average. 0, we can remove 3 into 6. V average, if you cross multiply 3 into 6, 18. 18 kilometer per hour, 16, 18 kilometer, option B. Simple. You please remember this formula only. For such problems, it is enough. Right. So in this problem, no numerical values are given. Only the notations are given for velocities. A body covers one-third distance with a velocity V1 and the second one-third distance with a velocity V2 and the remaining with a velocity V3. One-third, 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 V1, V2, V3. The average velocity. V average is equal to what? V average is equal to what? N by V average is equal to sigma 1 by V. N is equal to 3. V average. One-third, one-third, then total N is equal to 3. This is 1 by V1, then V2, then V3. V1, V2, V3, LCM. This is V2 plus V3. Then V1, V3, V2, V3 plus V1, V3 plus V1, V2. This is 3 divided by V average. Cross multiply it. V average is equal to 3 into V1, V2, V3 divided by 3 into, yes, V average will come here. This is V2, V3 plus V1, V3 plus V1, V2. This is the answer. Option B. 3 times V1, V2, V3, V1, V2 plus V2, V3 plus V3, V1. This is V1, V3. Yes. So use this formula and you can develop the remaining steps easily. Next problem. A person walks along a straight road from his house to market. House to market. Straight road. 2.5 kilometer distance. With a speed 5 kilometer per hour. The speed is 5 kilometer per hour. And instantly, immediately, he returns back and reaches his house with a speed 7.5. Market, then he is returning back, straight road, and reaches his house with a speed 7.5 kilometer per hour. When he is returning, this is onward journey, this is return journey. The average speed of the person during the time interval 0 to 50 minutes. So let us find how much time it is taking for him, because when he walks to the market with slow speed and returning fast 7.5 kilometer, right? So time 0 to 50 minutes. Average speed is equal to total, since distance is asked, speed is asked, total distance divided by total time. Total distance 2.5, speed only, not velocity. If it is velocity, 0 is the answer, because he is returning back to his house. So 2.5 plus 2.5, 5. This value is 5. Total time we must calculate. Then only we will reach the answer. Total time. How much it is taking? Kilometer is available. Look at the SI unit. Kilometer is available. Kilometer per hour is also available. So we can easily find how much time it is taking, right? Time is equal to onward time. Onward time. Kilometer divided by kilometer per hour. .5 divided by 5 is equal to 1 by 2. Kilometer and kilometer will get cancelled. Hour will go up. This is hour, but the answer must be given in meter per second. So half an hour is equal to 60 divided by 2 is equal to 30 minutes. Sorry, here minutes, right? 30 minutes. This is minute per second, right? 30 minutes. Return time. Return time. Same distance. Distance will never change. 2.5 kilometer divided by 7.5 kilometer per hour. So this is 1 by 3. 2.5 divided by 7.5 is 1 by 3 hour. This is because kilometer will get cancelled, hour will go up. 1 by 3 is 60 by 3 is equal to 20 minutes. So for reaching the market 30 minutes, from market to home it is 20 minutes, totally 30 plus 20, 50 kilometers in meter per second. So total time is 30 divided by 5 divided by 30 plus 20, 50 minutes. This is 2.5 kilometer, 5 kilometer, right? So it must be meter per second. So 5 kilometer is written as 5 into 1000 meter. 50 minutes is written as 50 into 60. 1 0, 1 0, another 0, another 0, this 5 and this 5. So 10 by 6. 10 by 6 meter per second or 5 by 3 meter per second. The answer is 5 by 3. So total distance 2.5 plus 2.5 total time, right? So we are checking whether the 0 to 50 is actually taken by the person. That is why we are writing these two steps. Next question, a student goes to school from home which is 2 kilometers away when he travels by road. Yes, a student goes to school from home which is 2 kilometers away when he travels by road. 2 kilometers. This is home. This dot is home and this is school. And net displacement is root 2 kilometer. It is lesser than, yes, usually. So I am joining by a straight line home to school. This is root 2 kilometer. But on the road it is 2 kilometer. This is 2 kilometer. It is more than root 2. If he travels by car on road with constant speed 20 kilometer per hour, right? 20 kilometer per hour. On the road only he can travel. Then the average speed and the average velocity of car. Average is, he is traveling 20 kilometer is given already. Speed, average speed, because it is constant speed. So constant speed, 20 kilometer, it is constantly he is traveling by car on the road. So it is not going to change. So average speed is always 20 kilometer. 20 kilometer per hour. Average velocity we must calculate. 20 kilometer, 20 kilometer, 20 kilometer. Option D will not be the right answer. 20 kilometer average speed, 20 kilometer average, 20 kilometer average speed. So average velocity we have to calculate. So V average is equal to displacement, total displacement divided by time. Displacement is available, root 2 kilometer. Time is not available. Time, how to get? From these two values, we are going to get the time. Kilometer to, by car, he is traveling the 2 kilometer with a speed of 20 kilometer per hour. 20 kilometer per hour. 20 kilometer per hour. Kilometer is cancelled. So this is 1 by 10 hour. This is the time. 1 by 10 hours he is taking. Displacement root 2. Root 2 divided by 1 by 10. Displacement root 2 kilometer. This is 1 by 10 hour. So the 10 will go up. 10 into root 2 kilometer per hour. This is V average. 20, 20, 20, 10 into root 2. Option C will be the correct answer. Yes. Next problem. If a cyclist takes 1 minute to complete half revolution on a circular path, it is not a straight line, on the circular path. To complete half revolution. So let it be the diameter for half revolution. To complete this half revolution, 1 minute time. 1 minute. Cyclist on a cycle, one person is riding on a cycle for half revolution 1 meter. Radius is 120. So this is 120 meter. What is average velocity during the time of 1 minute? What is average velocity? He is traveling on the circular path, right? From here it is starting, here he is ending. This is the starting place, this is the ending place. For displacement, we must join the starting place and the ending place. So this is the displacement. Not this line. This is the distance. This is displacement. Straight line joining the starting place and the ending place, right? Average velocity, V average is equal to displacement over time. Displacement, the radius is 120 meter. So this is nothing but the diameter 2 into 120. Time is 1 minute. The question, the answer is meter per second, meter per second. So 1 minute is written as 60 seconds, right? So this is 2 and the answer is 4 meter per second. 1 meter, 2 meter, option D, 4 meter. So displacement is the line joining the starting place and the ending place. Next problem. A body moves along a circular track. This is also a circular problem of radius r. Circular track, radius r. It starts from one end of a diameter, moves along the circular track and completes 1.5 revolution. 1.5 revolution. Revolution 1, then another half. 1.5 revolution. What is the ratio of the distance traveled, 1.5 revolution, by the body to its displacement, right? Displacement means he is coming here. The body is coming here. A body is moving, right? From here it is starting, it is moving. So displacement easily you can write. Like the previous problem, 2r. But the distance, the ratio distance to displacement is asked. Distance, 1 revolution, then half revolution. For first revolution, 2 pi r, circumference. Then the next revolution, pi r by 2. So 2 pi r by 2, pi r, divided by displacement is 2r, r plus r. From here it is the distance is, it is 2r. So this will be 3 pi r divided by 2r. R is removed. R. So 3 pi by 2 must be the answer. Option A. 1.5 revolution, 3 pi r. A body completes one round of a circular track of radius 20 meter. Yes, this is a circular track. One round of a circular track of radius 20 meter in 40 seconds. For one complete revolution, the time taken is 40 seconds. The displacement at the end of 1 minute 30 seconds. 1 minute and 30 seconds will be what? 1 minute 60, another 30, so 90 seconds. So to complete one revolution, 40 seconds. So from here assume he is starting, a body is starting 140, first 40, then second 40, then this is 10 seconds. 1/4, 10 second, 10 second, 10 second, 10 second. To cover one quarter circle, 10 second. Another quarter, 10 second. Another quarter, 10, yes, totally 40. So this is a time, 10 second, 10 second. So for 90 second, first 40, second 40, the body will be here. At the end of 90 seconds, that is 1 minute 30 seconds, 1.5 minute. At the end of 1 minute 30 seconds, the body will be here. This is the starting place, this is the ending place. The displacement is in question. For displacement, we must join the starting place and the ending place. Yes. Not the calculation of the distance, right? So this is also 20. This is 20. 90 degree, right? So this is radius. Let me write it as r. This is r. This will be root 2 r. Pythagoras theorem. If it is r, this will be root 2 r. R is equal to 20. Root 2 into 20 will be the answer. 20 root 2. Option C. Option C is the answer. 20 root 2. Right? So this is the starting place. 10 second, 10 second, 10 second. 10 second, 10 second, 10 second. At the end, he will be here. Simple. Next problem. A body covers an arc of circle of radius r, subtending an angle 120 degree at the center of the circle. The magnitude of the displacement of the body is what? A body covers an arc of circle of radius r. This is one circle, radius r. It covers an arc subtending an angle 120 degree. This is, let us say, this is arc. So this is 120 degree. 120 degree. From here it is starting, from here it is moving. This is the arc it is traveling. The radius is r, the angle is 120 degree. The magnitude of the displacement of the body, right? The magnitude of the displacement. Displacement, once again we will join the starting end and the finishing end. This is starting end and this is the finishing end. This is the displacement. So this is nothing but a chord. Length of the chord must be the answer. This is radius. Green line is radius. This yellow line is chord. The length of the chord is what? Length of chord is answer. So from mathematics, we have known this formula. Length of the chord is equal to 2r sin theta by 2. 2r sin theta by 2. R is available, theta is also available, 120 degree. So 2r sin 120 by 2 is 60. 2r sin 60. Sin 60 is root 3 by 2. 2r root 3 by 2. 2 is removed. The answer is root 3r. Root 3r, option D. Yes. Length of the chord formula you must remember. To solve this problem, length of the chord. Next problem. A particle starting from point A, traveling up to B with a speed v. From A to B with a speed v. Then up to point C with a speed 2v. And finally to A with a speed 3v. As shown in figure. Determine its average speed. Average speed must be calculated. Average speed means it is distance by time. So this length we must find, and this length we must find, and this length we must find, because it is different velocities, v, 2v and 3v. So this is one arc, this is another arc, this is another arc. The entire circle is divided into 3 arcs. So length of this arc A to B we have to calculate, B to C, then C to A. Length of the arc. Remember this formula. Hopefully you are knowing this formula. Arc is equal to rad. This is how I will remember. Arc length is equal to rad. The first rad is radian, then multiplied by radius. This is rad, arc length. Radian, radius. Radius, let us assume it is r. How it was obtained, right? Assume this is one half circle. This is 2 pi r divided by 2. This is pi r, half circumference. If it is full circumference, 2 pi r, but this is half circle. So 2 pi r divided by 2 is equal to pi r. Pi r, I am writing pi into r, radian into radius. Then this is quarter circle. Full circle is 2 pi r, quarter circle is 2 pi r by 4. This is pi r by 2. I will write pi by 2 into r. Radian is pi by 2, 90 degree. So radian times radius, right? So let us say this is L1, this is L2, and this is L3. 3 arcs. Radian into radius. Radius, let us assume r, right? Radius is not given, but let us assume L1 is equal to, what is the angle? 90 degree. Radian, you must write in terms of radian. So pi by 2 into r, L1. L2, 120 degree. So 2 pi divided by 3 radian. 2 pi is 2 into 180, 360. 360 divided by 3 is equal to 120 degree. So 2 pi r, radian times radius. Then arc L3. Arc L3 is, this is 120 plus 90, this is 210. So this must be 150 degree. It is not given, 150 degree. 120 plus 90, 210. So 360 degree from 210 is 150 degree. This will be 5 by 6 pi. 5 into pi is 5 into 180, 90 degree. 90 divided by 6 is 900 by 6 is 150 degree. So 5 by 6 pi. 5 pi by 6 radian into radius. Rad. Radian into radius. So L1, L2, L3 I have found. I am going to calculate what is average speed, right? Average speed is equal to total distance divided by total time. Total distance is L1 plus L2 plus L3. Straight away we can write L1 plus L2 plus L3, 2 pi r, isn't it? Circumference only. Straight away I will write total distance is the circumference value. Total time, this distance divided by this time. Let us say this is T1 seconds, this is T2 seconds, and this is, so V is, it is available, right? So straight away we will use the V value. D divided by V, that is length divided by V. L1 by V, L2 by 2V, L3 by 3V. So total time. L1 by V plus L2 by 2V plus L3 divided by 3V. This is total time. Distance per velocity. Distance per velocity. Distance per velocity. 2 pi r. Then I am going to replace L1, L2, L3. The arc lengths. These are the arc lengths. Arc length L1 is equal to pi r by 2. Pi r by 2. Then this V. L1 is pi r by 2. Speed is V. Then 2 pi r by 3. L2. 2 pi r by 3. This V. 2V. Isn't it? 3 into 2V. Plus 5 pi r by 6. L3. 5 pi r by 6 into 3v. This is the time t1 plus t2 plus t3, right? Pi r we can remove, 2 pi r. So pi r we are taking outside to remove 1 by 2v plus 2 by 6v, 2 by 6v plus 5 by 18v. Pi r is removed. So average speed is equal to 2 divided by 1 by 2v plus 1 by 2 by 6v plus 5 by 18v. 18v we will take as LCM. Two divided by 18v, it is 9 plus 3 times, then 3 into 2 6 plus 5. 2 into 18v divided by 9 plus 6 plus 5, 20. So this is the 2 is removed, 10. 18v divided by 10 is equal to 1.8v. Average speed is 1.8v. 1.8v, 1.5, yes, option A. So arc length is radian into radian. This length, this length, this length I am calculating separately because v is given, v, 2v, 3v, we need total time. That is the idea. Next problem, a ball thrown vertically up with a speed v comes back to the starting point, right? The ratio of distance covered and displacement. Distance divided by displacement. It is traveling some distance. Let us say it is h meters. 2h. h meters it is going up. Then it is again h meters coming down. Displacement, it is coming back to the starting place. 2h by 0. Infinity is answer. 0, 1, minus 1, infinity. Simple. Yes. Next question. A person goes to his office from his home daily at a fixed speed. From his home to office. This is home. Then this is office. Office. With a fixed speed, right? He decided to reduce his speed. Speed reduced by 20%. As a result, he reaches his school 16 minutes late. So this is person to his, not office, this is school, right? Typing mistake, it is school. 16 minutes late. Since he is reducing the speed, it is late by 16 minutes. Yes. When you reduce the speed, yes, definitely you will reach the place lately. What is the actual time he takes to reach his school daily? Daily he has one speed. On that particular day, he is reducing the speed. He is slowly walking. Daily. So, two cases. Case 1, time he takes, right? Case 2, with reduced speed. So let us say this is v, reduced speed will be 0.8 v, slowly 20% it is reduced, right? Time, if we assume this is time, then this will be t plus 16 minutes, because time taken will be more, 16 minutes higher than the previous regular time. This is regular speed and regular time. This is the speed he is used on that particular day, 0.8 v, 20% it is reduced. But the place is not changed, so distance is same. In both the cases, s equal to s, isn't it? School to his home, s is equal to s. S is equal to time into velocity. S is equal to time into velocity. In case 2, time is t plus 16. Velocity is 0.8 v. So v we can remove. So t is equal to 0.8 times t plus 16 into 0.8. 0.8 t is taken this side. So this is 0.2 t. 16 into 0.8. T is equal to 16 into 0.8 divided by 0.2. 0.8 by 0.2 is 4. So this is nothing but 16 into 4. So this is 32, 64. 64 minutes, right? Everything is minutes. 64 minutes, MIN. So the answer is, it is given in terms of hours. So 64 minutes is equal to 1 hour 4 minutes, right? Case 1, this is the regular time. 64 minutes he is taking regularly, but on that particular day it is coming more by 16 minutes because he is reducing his speed. Average velocity and instantaneous velocity, right? So average velocity between a time interval, right? Half an hour or 1 hour or 10 seconds or 10 minutes, right? Time interval. So we average is equal to delta v divided by delta t. Change in velocity. Final velocity minus starting velocity divided by final time minus initial time. So let us write it is initial. Final minus initial. Final velocity minus initial velocity. Final time minus initial time. So this is average. So the time interval is a bigger one. Instantaneous, this formula. dv by dt, you have to differentiate. Instant at one particular instant, right? So this may be some 2 seconds or 5 seconds, say 10 hour 30 minutes 02 seconds to 10 hours 30 seconds 0 to 5. So this is the interval is 3 seconds. The difference is 0.5 minus 0 to 3 seconds. But here exactly at 10:30:05, what is the speed or what is the velocity? So this is instant. Exactly at a particular instant. To know the velocity or speed on particular instant, we have to differentiate with velocity. So v instant is equal, no, I am sorry, it is a distance. I am very sorry. Distance by time. Yes. Delta S by delta T, meter per second. So initial, final minus initial. Distance covered. How much distance you have covered? Then this is final time minus initial time. So this is ds by dt. Exactly at one particular instant, how much distance it is, he has traveled, how long, that is instant, at one particular instant. So you have to differentiate it, right? So average velocity and instantaneous velocity, you please remember these two formulas. We will be using these two formulas for solving the remaining problems. The position of the object moving along the positive x-axis is given by x is equal to 8.5 plus 2.5t. So viewers, please remember, in the previous problems, we were given some 20 km per hour, 30 km per hour. Yes, some numerical values we were given. The time is also given, or velocity is given. So we use the formula V average is equal to total distance or displacement over total time. But in another 2 or 3 problems, we need to use this formula, differentiation formula or the delta formula, incremental formula, because the values, the question is going to be coming with equations. Equation related problem I have taken now. So x is equal to 8.5 in this problem, x is equal to 8.5 plus 2.5t. X or s, distance, where t is in second. Then the average velocity, V average between 2 to 4 seconds. Time interval is 2 to 4 seconds, right? Average velocity is delta x by delta t. The earlier problems we used this formula, total distance by total time, because we were given the actual values, numerical values, but here in the equation format it is given. So I am using this formula, delta x. So distance at fourth, final time, distance at fourth second minus distance at second divided by the time is 4 minus 2. Then x is given in a equation, 8.5 plus 2.5 t, we will substitute 4. This is final distance minus initial distance is 8.5 plus 2.5 into 2. Here time is 2 divided by 4 minus 2, it is 2. So this is 8.5 plus 4 into 2.5 is 10 minus 8.5 plus it is 5. 8.5 plus 5 divided by 2. This will be 18.5 minus 13.5 divided by 2. So this is 18.5 minus 13.5, 5. 5 by 2. Yes, this is 2.5 meter per second. Option A. So if the question is coming in equation form, you must use delta x by delta t to calculate V average. This formula cannot be used, right? If it is V instant, dx by dt. Next problem, if the particle is moving along a straight line given by the relation x is equal to 5 minus 6t plus 2t square, where x is in centimeter and t is in second. Its average velocity during the third second. Average velocity during the third second. Third second. What is V average? That means it is divided in terms of seconds. Third second means already first second is there, second is there, third second. So between second to third second, right? So average velocity is equal to delta x by delta t. What is the time? Final time is third second. So initial time means second, right? If the word third is there, second will be also there, first will also be there. So the time interval is first second, third second, in terms of seconds only, not millisecond or microsecond. So third second, final time. So second, initial time. This is the time interval for this case. Then x at third second minus that is the distance covered, x at second. The x is given as 5 minus 6 into 2, t is equal to 3 here, plus 2 of t square, t is equal to 3, so 3 square. This is the final distance. Then similarly, initial distance, 5 minus 6 into t is equal to 2 plus 2 of 2 square divided by 3 minus 2 is equal to 1. Then V average is equal to 5 minus 6 into 3, 18, plus 2 of 3 square. 3 square is 9, it is also 18, minus 5 minus 12 plus 2 of 2 square. 2 into 2, 4, 4 into 2, 8, divided by 1. So this is 18 and 18 are cancelled. 5 minus 5 plus 8 is 13. 13 minus 12 is 1. 4 meter per second or centimeter, where x is in centimeter. So the unit is centimeter per second. 4. Option C. 4 centimeter per second. Next problem. The distance travelled by an object along a straight line in time t is given by s is equal to s or x. Both the letters can be used. 3t minus 5. 8t square plus 3t minus 5. The distance s in meters. The initial velocity. Initial velocity. This is talking about the instant. Initially, when it is started, not between one time interval, right? So initial velocity, that means v instant. We have to calculate v instant, not a time interval. So v average formula will not be used here. V instant is equal to differentiate it, ds by dt. Initial velocity of the object. Initially time is equal to 0. Differentiate it and make t is, or put t is equal to 0, you will get the answer. So differentiate it. 8t square, 2 into 8, 16t. So you need to remember the differential formulas, all the differentiation formulas. 2 into 8, 16t plus 3. 3t differentiate 3. So constant, it is 0. So the differentiation is 16t plus 3. So v instant is equal to 16t plus 3. So initial value, initial v instant is equal to, at time t is equal to 0. Initially time is 0, right? So 16 into 0, so 3 will be the answer. So meter per second. So it is not given, unit is given. 3 unit, option A. Yes. Next problem. The motion of a particle is described by the equation x is equal to a plus bt square, where a is equal to 15 centimeter, b is equal to 3 centimeter square. It's instantaneous velocity, simple. So differentiate, let us differentiate it. So x is equal to, we will substitute the numerical value is given 15 plus 3t square. V instant is equal to dx by dt. 15 is 0, 3t square is 60. The instantaneous velocity at time t is equal to 3 seconds. So at t is equal to 3 seconds, 6 into 3, v instant is equal to 6 into 3, 18. What is the unit? Centimeter. So this is also centimeter, this is also centimeter, 18 centimeter per second. Option D. Next problem. The displacement y, here it is y is used in this problem. X, yes, here y. So displacement y in meter of a body varies with the time t in second as y is equal to, it is also given in the equation format, minus 2 by 3 t square plus 16t plus 2. How long time the body will take to come to rest? The body takes, how long time the body takes to come to rest? How long time the body will take to come to rest? At rest means the body will not move, motionless. So at rest, velocity will be 0. So this is the condition. So we have to substitute v is equal to 0. In the previous problem, initial velocity, so we substituted t is equal to 0. But here at rest, that means we have to substitute v is equal to 0. So y is equal to some equation. V we have to calculate instant, because this is also one instant, one particular instant the velocity is going to be 0. The body is going to take rest. So v instant is equal to dy by dt. Let us differentiate. Minus 2 by 3 constant, it is t square, so this will be 2t, differentiation of t square. Differentiation of 16t with respect to t, 16. Differentiation of 2 constant. So this is minus 4 by 3 t plus 16. At rest v is equal to 0. So v instant is going to be 0 at rest. So this is 0. So we will equate it. Minus 4 by 3 t will come here. Left hand side is equal to 16. Right? So t is equal to, cross multiply it, 3 into 16 divided by 4. 4 table. 1, and this is 4, this is 12. Answer is 12. Option B, 12 seconds. So initial velocity, we will substitute t is equal to 0. At rest, v is equal to 0. Yes. Next problem, two cars P and Q start from a point at the same time. Two cars, car P and car Q, exactly at the same time it is started in a straight line, and their positions are given, represented by x of p of t is equal to at plus bt square, and x q of t is equal to ft minus t square. At what time do the cars have the same velocity? At what time? At what time the cars have the same velocity? Two cars are started at the same instant. Its velocity is, its distance is given by this equation, its distance is given by this equation. Distance versus time. So when time is changed, the distance will be changing. Time is changed, distance will be changing. At one particular time, both the cars will have same velocity at one particular instant. So we have to differentiate it. dxp by dt for car P. This is differentiation of at is a plus differentiation of b is constant. Differentiation of t square is 2t. So this is 2bt. And if you differentiate it, d by dt, dxq by dt is equal to ft. Differentiation of ft is f. Because with respect to time only we are differentiating, minus 2t. So this is velocity of car X. Car P. This is velocity of car Q. Velocity of car Q. So at one particular instant, both the velocities are same. So Vp is equal to Vq. That is A plus 2bt is equal to f minus 2t. A plus 2bt is equal to f minus 2t. So time, we will group them. 2bt plus 2t is equal to f minus a. So 2t is constant. B plus 1 is equal to f minus a. So t is equal to f. At this time, both the velocities are same. F minus a divided by 2 of b plus 1. At this time, both the cars will have same velocity. We will check the options. F minus a, f minus a, f minus a, 2 of b plus 1, 2 of 1 plus b. Yes, option B is right. This is a minus f, this is a plus f. Yes, option B is correct. Yes, bird problem. A bird moves in such a way that it has a displacement of displacement. So straight line. 12 meters towards east. 12 meters towards east. Let us say this is east. 5 meters towards north. 5 meters, yes. And 9 meters vertically upwards. Find the magnitude of its displacement. So this is a 3-dimensional problem. X, Y, Z we have to use. This is x-axis and this is y-axis and this is z-axis. This will be minus x and this will be minus y and this will be minus z, right? The vector algebra, you must have studied this 3-dimensional representation. This is east. We will consider this is east direction and this is minus z is north direction and this y is top to sky, right? This is to sky, y direction. So minus x means it is west direction, plus z means it is south direction, south, and this is west. Yes, a bird moves in such a way that it has a displacement of 12 meters towards east, 5 meters towards north, and 9 meters vertically upwards. This is 5 meters and this is 9 meters. This is the place where it started to fly, move. 12 meters, then north direction it is taking, east direction, then north direction, then it is going up 9 meters, right? Find the magnitude of its displacement. This is where the bird now. East direction, assume this is east direction, then comes here, then comes up. So this is the starting point, this is where it is available now. We have to connect these 2 points, right? So the distance of one vector. You must remember this formula, right? Square root of extension of Pythagoras. 12 square plus 5 square plus 9 square over. Like Pythagoras theorem, we will extend it. 12 square, one dimension, 5 square, another dimension, 9 square. Twelve square is 144 plus 5 square is 25 plus 81. Even though if it is minus z, so you may assume this is minus 5, but when it is squared, minus 5 square is going to be 25. We need not worry about it, right? So 144 plus 81 plus 25. This is 4 plus 5 plus 1, 0, 5 plus 2, 7, 5, This is 2. This is 250. Square root of 250. The options are 5 root 2, 5 root 10, 5 root 5, 5. So 5 is available in all the options. So 5 means inside the square root 25 must be there. Then only if you take 25 outside, 5 you will get. So 25 into 10. This is 5 root 10. 5 root 10. Option B is right. Yes, this is the last problem we have considered, viewers, right? Do not remember too many formulas. Very few formulas I have used to solve almost 25 numericals in this video lecture, right? So this formula will be very, very helpful. N by V is equal to sum of 1 by V. Then chord, length of chord, 2r sin theta by 2. This formula we have used. Then arc is equal to rad. Radian times radius. So these are the 3 formulas we have used. Then the concept we exploited, all the concepts we have exploited to solve the problems, right? Right guys, thank you for watching. All the best.